Hello. In this video, we're going to go through and discuss verifying trig identities. Okay, so basically, the idea here is that we're going to be given a trig equation such as this one, and then try to verify it. Okay, so all right, and so we're going to go through several. I'll go through several examples and talk about the various strategies. Okay, and we'll definitely apply those. And then so that we can verify these, okay? So we're gonna start off with this one, as you can see here, and then we'll do some more complicated ones, okay? All right, so we wanna show, right? We wanna show that tangent theta over secant theta is equal to sine theta, okay? All right, so sometimes, so a lot of these type of problems, it's best to basically simplify everything in terms of either sine or cosine, and then perhaps something will cancel out. Okay, so let's take a look at this one here. Okay? So we know that tangent theta, right, is equal to sine over cosine theta. Okay, so let's apply that to here. Okay, so for the top part, okay, we're going to get sine theta over cosine theta, and all this is divided by secant theta. All right. And so, again, so the goal is to put everything in terms of sine and cosine, right? And hope that something may simplify or cancel out. All right. So secant theta, we know secant theta, right, is the reciprocal of cosine theta. Okay. All right. So we can go from here. This is just sine theta over cosine theta, divided by 1 over cosine theta. All right, so this is tangent, okay, right? Secant is 1 over cosine theta. So now we have this divided by this, okay? So what we can do is basically change this into multiplication. And the way we do that, if you recall, we can do that from algebra, right? We can do the same thing here for this expression, okay? So we can take and write this as sine theta over cosine theta, okay, times the reciprocal of this. So that's going to become cosine theta over 1. So now you can see that cosine thetas will cancel out, and that leaves us with sine theta over 1, which is sine theta. Okay, so that's what we wanted to show. All right, so we showed that this tangent theta over secant theta is the same thing as sine theta. So another way to think about this is that if you're to graph this, okay, if you're to put this into, let's say, decimals, right? If you graph this one, then it would look like, or it would look exactly like sine of theta, okay? So these are basically, these are the same function, right? Therefore, it gives you the same graph, okay? So this is really beneficial, and you'll see why later. Because we're going to be working with what's called trig equations, where we need to solve for a certain variable. Okay, so sometimes we may have to simplify certain components, and then apply some other techniques to solve for that particular variable. All right. So let's look at another one. All right, so let's say I have 1 over 1 minus sine of u, okay, plus 1 over 1 plus sine u. And we want to show that this is the same thing as 2 secant squared u. Okay. Okay, so how to do this one? All right, so we're going to use the idea of what's called the conjugate, right? So what does that mean? Well, what we're going to do is, the idea here is that we can take this side, okay, and multiply it by its conjugate, which happens to be this, okay? All right. So in other words, okay, we want to come up with a common denominator, right? Okay. So it just so happens that in this problem, the conjugate of this is this one, and the conjugate of this is this. Okay. So we want to multiply the right, we want to multiply this side by 1 plus sine of u. Okay. Right. Right. So we need to come up with a common denominator. Okay. So if I multiply, right, so in other words, I need to get 1 minus sine of u and 1 plus sine of u together, right? So I want to put this under the common denominator, right? So I need to multiply this one by 1 minus sine of u. Okay, so this is what we have. Okay, and then likewise over here, I need to multiply this by 1 minus sine of u. Okay. So I'm going to need to put parentheses here just because we're multiplying. So again, so given something like this, right, we need to add them together the way we put them under, so we need to combine them, right, under a common denominator. Okay, so to do that, I have to multiply this by 1 plus sine of u, okay, and right, and if I do that, if I multiply on top here, I need to multiply on the bottom, otherwise I'm changing the original problem, right? And then on this side, I need to multiply by 1 minus sine of u, but then I need to multiply on the bottom, and you can see that now, right, we have this, right, we have this in the denominator here, and the same thing here, so now we can put everything together. So we're going to get 1 plus sine of u, okay, and then plus 1 minus sine of u, all divided by the common denominator of 1 plus sine of u times 1 minus sine of u. Okay. So that's all under this common denominator. Okay. So right away, you notice that if you look at the numerator, right, the sine functions cancel out. Right? So we're going to end up getting, okay, 2 sine of u. Oh, sorry, not 2 sine of u. Sine of u cancels out. We're going to get 2 though. Okay, so sine of u minus sine of u, and then we have 1 and 1. So that's going to give us 2 divided by, okay. So on the bottom here, we can go ahead and multiply this out. So we have 1, okay, 1 times 1, that's obviously 1, minus sine of u, plus sine of u, okay. So we have 1, okay, 1 times sine of u, which gives us this, and then sine u times 1, and then plus sine squared u. Okay. So as we expect, because this is really like a plus b times a minus b, and if you recall from algebra, that's just a squared minus b squared. So that's all that's happening here. And so the middle term cancels out here, okay? So this part right here, right, this is going to be 0. So we have minus sine u plus sine u, 0. So we're left with 2 over 1 plus sine squared u. Okay. And this should be, this is going to be minus here. Sorry, I overlooked that. So plus and minus, that's minus. Okay. All right. So again, 1 plus sine of u times 1 minus sine of u. Okay, so we're going to get 1. We get minus sine of u times, right, minus sine of u plus sine of u. And then sine of u times this gives us minus sine squared u. Okay. And from here, okay, right, this is one of the identities that we talked about, right? So this is, so 1 minus sine squared u, okay, that equals to cosine squared u. Okay, why is that? Well, if you recall, let's do that over here. Okay, should never forget this identity. This is one of the Pythagorean identities. Okay. So in this case, right, we can solve for cosine squared theta. Right? So this cosine squared theta is just 1 minus sine squared theta. So I can move that over there. And so now we have a representation for this in terms of sine. So going back over here, okay, right, I have 1, right? We have 1 minus sine squared u, okay? So this property always, this identity always applies, no matter, no matter what the symbol or letter that we're using, okay? So here I'm using theta, here it's u, so it's the same, right? It's a function, okay? So 1 minus sine squared u, according, right, from here will be cosine squared u, okay? Okay, so there we get 2 over cosine squared u. So now, remember that 1 over cosine is secant, okay? So that's what we can write here, okay? We have cosine squared u in the denominator. So this is the same thing as writing it this way. And because it's squared, then we have to keep that, right? Okay, so there's our results, right? This is what we wanted to show, okay? Again, so we have something like this, okay? You take this side, right? Multiply top and bottom by this, okay? And then from here, right, for this side, multiply it by this one, okay? And from there, hopefully something will cancel out, okay? Which in this case, something does cancel out, that is the sign used. That leaves us with 2 on top. And then for the bottom here, you can just multiply this out and you're left with this. And this reduces to this. And we know that this is, from this identity, is cosine squared u. And 1 over cosine u is secant u. Therefore, 1 over cosine squared is also the same as saying secant squared u, okay? All right. Okay. All right, let's look at the next one. So the next one we want to show that sine theta over 1 plus cosine theta is equal to 1 minus cosine theta all divided by sine theta. Okay. Now technically, we have some of these, right? You could cross multiply here, but sometimes, you have to be careful with that, especially, if we're, dealing with like more complicated things. But so ideally what you want to do, a more ideal way to show this is to pick one side. And so that's something I forgot to mention over here. So usually the side that we start out with, usually when I start with the side that looks more complicated. Okay, for example, back to this one. This part looks more complicated than this one. So that's why we started here, because we have more pieces to work with. Okay, so now going over here, it looks about, this one and this one, there's really not much difference here in terms of the complexity. So we could either start out here and then go through steps to get to this side, or we can start out here, go through the process and then get on this side, okay? So in this case, what I'm going to do is I'm going to start on this side, okay? And then go through the work and show you that you can end up getting this, okay? So let's start that. So we have sine theta over 1 plus cosine theta, okay? So here what we need to do is we need to we need to use what's called the conjugate. Okay, kind of what we did here. Okay, basically like I said, the conjugate of this is this one, and the conjugate of this is this. Okay, so they happen to be conjugates of each other. That is one of the reasons why why we were able to simplify this. So going back over here, right, we need to use the conjugate of this. Okay, and so using the conjugate, things will simplify. All right. Okay, so we're going to take the conjugate of 1 plus cosine theta. So the conjugate of that is going to be 1 minus cosine theta. Okay, so again, so if this is plus, this has to be minus. They have to be opposites. Okay, so if I'm multiplying this by the denominator, I need to do the same thing on the top. Otherwise, I'm changing the original problem. Okay, so notice this, right? Okay, this is still the same thing as this. Right? We didn't change anything here. In fact, this is, if you think about it, this is just 1, right? Okay. So now, what this is going to do is actually, this is going to simplify things. Okay, as you'll see. So this is going to be sine theta. Okay, we can distribute this minus sine theta times cosine theta. So distributing, okay, all divided by, okay, again, we have this, which is, we can multiply this out just as we did over here, okay? So again, think of this as A plus B times A minus B, okay? So this is going to turn out to be 1, we're going to get 1 minus cosine theta, and then we get plus cosine theta, okay? So we're going to end up getting 1 minus cosine squared theta, okay? Because the two middle terms, just as what happened here, it's going to give us 0. And then we get cosine theta times negative cosine theta, which is cosine squared theta, okay? In fact, I can work that out in detail on the side here. So let's go through that here. Okay, but it doesn't hurt to work this out. Okay, so it's just going to be 1 times 1, right? Okay, then we get 1 times minus cosine theta, and we get cosine theta times 1, and then we get minus cosine squared theta. So this, right, so this is going to be, again, this is going to be 0. Because we have minus cosine theta plus cosine theta, which is obviously 0. And so we end up with 1 minus cosine squared theta. So it's the same idea with what, in algebra, right? We had that special formula, right? A minus B, okay, times, or in this case, let's keep it as A plus B and then A minus B. So when you multiply this out, you're getting A squared minus B squared. So this is really just you're just basically applying the difference of two squares. Okay. So instead of doing all this, what you can do is you can just identify, okay, so this is A, this is B. So, and then we have plus or minus, right? So that tells us that we need a minus here. Take 1 squared, which is 1, take cosine theta and square it, and you get this. So that's just coming from this, okay, from this property. All right. So anyway, but in any case, if you forget this, you can always multiply up by hand. All right. So let's go on to the next part. Okay. Notice that we get sine theta here and sine theta, so we can obviously factor out that. Okay. Let's go down here. That's going to leave us with this. And then on the bottom here, we have 1 minus cosine squared theta. Again, from the Pythagorean trig identity, that's equal to sine squared theta. Okay. All right. Okay. So again, we have sine squared theta plus cosine squared theta. Again, you should always remember this. It comes up in a lot of different ways. So we can get, right, if we, right, to get this, right, we just move that over. So we have sine squared theta equal to 1 minus cosine squared theta. So this becomes this. And so now we can cancel out the sine theta. Okay. So this is going to be 1 minus cosine theta. We can cancel out one of these, right? That's going to, so this is going to cancel out this one, and that's going to leave us with a sine theta on top. And that's what we want to show. Okay. So a lot of the steps involved are basically just the algebra, right? So instead of working with letters here, we're working with trig functions. Okay. So the process is really the same. Okay. Okay. All right, let's look at the next one here. Okay, so let's say we have sine theta times cotangent theta minus or plus tangent theta. And we want to show that this is equal to secant theta. Let me lower this a little bit. Okay. So again, we start with the most complicated. We start with the more complicated side. Okay. So there's more functions here than there is here. So we have more to work with. Okay. All right. And so we're going to go through this. Okay. And the hope is to, right? Our goal is to get to this point. Okay. So make this look like this. Okay. So again, a good strategy is to write everything in terms of the two basic trig functions. Those being the sine and cosine theta functions. Okay. So we have sine theta. So let's write that down. Cotangent theta, right, is basically 1 over tangent theta. So that's the same thing as cosine theta. Right? If you remember from the previous chapter, right, this is cosine theta over sine theta. And then tangent theta, that is just sine theta over cosine theta. Right? So again, we use this, right? We use this property. Okay. Okay, cotangent theta is 1 over tangent theta, which is the same thing as cosine theta over sine theta. Okay. And then we know that tangent theta, right? Tangent theta is just sine theta over cosine theta. So we have everything now in terms of sine and cosine. So the next thing is what we can do here is, we can go ahead and let's go ahead and distribute this, okay, this sine function. So we end up getting, when we distribute this, okay, we end up getting sine theta times cosine theta, all divided by sine theta, plus sine squared theta over cosine theta. Okay. And so, right, you notice that this can cancel out. Okay, so we have cosine theta, okay, plus sine squared theta, okay, over cosine theta. All right. So let's write it this way. Okay. All right, so we're at this point. Okay, so again, what we can do here, a lot of times if we have something like this, the strategy is to put something, put this over a common denominator. The common denominator here, well, since this is just, think of this as 1, because remember we cancel this out, so 1 gets replaced there, but we normally don't write it, but this is just for illustrative purposes. Okay, so our common denominator is going to be cosine theta. So we can multiply this side by cosine theta. So that way we can put everything under a common denominator. Okay. So I'm going to take this side, okay, multiply it by cosine theta. Okay, and that way now we get cosine squared theta plus sine squared theta, all divided by cosine theta. Okay. So now, again, we see that we need to apply the Pythagorean identity, which is here, right? So this is going to be, this is equal to 1 divided by cosine theta. And 1 over cosine theta, right, that is equal to secant theta. All right, there you go. So that's what we wanted to show, right? So again, this is quite useful, right? So you're taking an expression here and reducing it down to this one. Okay, so this is just the same, right? This is basically the graph of this is the graph of this function. Okay. All right, let's say we have cosecant theta minus cotangent theta. And we want to show that this is sine theta all divided by 1 plus cosine theta. Okay, so let's see. So there's several, this one is, this side looks, just as complicated as this side. And so, so we could technically start from either side here in this case. So, but for the purpose of this, what we can do here is we can rewrite this side all in terms of sine and cosine. And when we do that, that's actually going to look a little more complicated than this side, okay? And so then that we'll have more, right? We have more to work with, okay? So let's try that, okay? So let's try to write everything, start on this side, write everything in terms of sine and cosine, okay? So we know that cosecant theta is this 1 over sine theta. Cotangent theta, remember that's cosine over sine. And so what happens here is really nice, actually, because it really works out because gives us a common denominator. Okay. Right. And so now we have this. So we have 1 minus cosine theta all divided by sine theta. Okay. Okay. So again, what we need to do here is use the idea of the conjugate. Okay. All right. So we have 1 minus cosine theta here, okay? So we can go ahead and multiply this side by 1 plus cosine theta, okay? So if I multiply the top by 1 plus cosine theta, I need to multiply the bottom by the same thing, right? So again, so if this is plus, right? If this is plus, this needs to be minus. Okay? They have to be, right? The signs. Okay, these signs have to be the opposites for this to work. Okay, have to be the opposite value. So that's what I'm saying is that, right? This, the conjugate of this is this, and vice versa. The conjugate of this is this. Okay, and we should put parentheses here. Okay, to indicate that we're multiplying all this with all this. Okay. So let's multiply the top part out. Again, we have this. We have 1 minus, right? We're A minus B times A plus B. So we're going to end up getting 1. So we can basically square 1 and then square cosine. So we end up getting 1 minus cosine squared theta, okay? Using what I just discussed earlier, okay? And then on the bottom here, we have sine theta times 1 plus cosine theta, okay? Okay, again, so we have 1 minus cosine squared theta, that is equal to sine squared theta. Right. And so sine theta, right, and sine theta will cancel out here. Okay, so we're going to be left with sine theta all divided by 1 plus cosine theta. And that's what we wanted to show. Okay. So now we could have it's possible that we could start on this side and use the conjugate here and then try to end up with something like this. But it may be a little more difficult. Okay. So if you come across a situation, if you pick one side and you start to do the work, and if you notice it's getting really complicated, well, just go to, scratch that idea, right? And then just go and start with the other side, see what happens. Maybe picking the other side is a lot simpler, okay? So we don't need to, you just need to use one side to show the other side, okay? All right. Okay. Let's go to the next one. Let's see. I think for the most part, I think most of you find this very, very, fun to do. They're kind of like puzzles. All right, number 6. Okay, let's see. All right, so let's see. I want to show that sine squared theta. It's a little bit too high there. Let me adjust this. Okay. So we want to show that sine squared theta minus tangent theta all divided by cosine squared theta minus cotangent theta is equal to, let's see, tangent squared theta. So in a way, if you think about these are, you can think of these are identities, right? Okay, but sometimes, we don't need to memorize. We can just work them out this way to show that they're, to use these. Okay. All right. Again, so obviously this side is more, obviously this side is more complicated here, right? So sometimes, you just, sometimes going the other way is a lot more difficult, right? But I mean, like if we start from here and we want to go this way, that would be extremely difficult because we only have this function, right? Okay. So this is another, right? So obviously starting on the left-hand side would be ideal. All right. So again, what we can do here, just like we did here, is to rewrite everything in terms of sine and cosine, okay? All right, so we have sine squared theta, tangent theta, it can be written as sine over cosine, so sine theta over cosine theta, and then we have cosine squared theta minus cotangent theta. So cotangent theta, again, that is 1 over tangent theta, which is the same as cosine theta over sine theta. Okay. All right, so now what we have is we have basically what's called a compound fraction. If you remember what those are from the previous course, that is basically we have a fraction, right? We have a fraction within a fraction. Okay. Okay. So sometimes these are called complex fractions or compound fractions. Okay. So the way we can simplify it is to look at the denominators, okay, and then use the least common multiple of those, and then multiply that. Take that function and multiply it by the top and bottom. So we have cosine theta here and sine theta. So obviously taking the product of sine cosine, that will give us the least common multiple here. Okay. In other words, least common multiple being the same as the least common denominator, because these are in the denominator. Okay. So we're going to take the top, multiply it by sine theta times cosine theta divided by same expression, same function. So what this is going to do, it's going to clear out the fractions for us. Okay. So this is sometimes referred to as clearing out the denominators. Okay. All right. So again, taking this times this. Okay. Okay. And then for the bottom, we get cosine squared theta times sine theta, okay, minus. Oh, let's see. We need that cosine theta, okay? And then minus, we have, so what's going to happen here is that, okay, so going back up here real quick, the cosine, so I'm going to write the cosine theta here. I got to put that. Okay. But you can see it's going to cancel out, but I just want to write it out for illustrative purposes. And then right here, we're going to get cosines, so we're going to get cosine theta, okay, times sine theta, times cosine theta, all divided by sine theta. Okay. Okay. All right, let's go over here. So as I mentioned earlier, right, this is going to, right, this will cancel out and this will cancel out. And that was the purpose for doing this step. It's because it will clear out these denominators. Okay. So let's put everything together. Okay, so we have sine cubed theta times cosine theta. And then we have over here, we have sine squared theta, all divided by. Here we have a cosine squared theta, and we have a cosine theta. So that's going to give us cosine cubed theta times sine theta minus cosine squared theta. Okay, again, that's going to cancel out. Okay, so we're left with this. Now we can see that we have a sine cubed theta and a sine squared theta. So we can factor the sine squared theta out. So that's going to give us sine theta times cosine theta minus 1. Okay, divided by, we can take out cosine squared theta. Okay, we have right? Because we have a cosine cubed theta here and a cosine squared theta. So we can factor out a cosine squared. That leaves us with cosine theta times sine theta minus 1. Okay. Notice that this is the same as this, right? Because sine theta times cosine theta is the same as cosine theta times sine theta, right? So this is the same. So this, right? This will cancel out with this. Basically just 1, right? And we're left with sine squared over cosine squared theta. okay, which reduces to tangent squared theta. Since sine over cosine is tangent, right? So, but we have a square here, okay? So there it is. We showed, right? We showed that this is equal to tangent squared theta, okay? Right? So again, the way we have to, right? If you have something in the denominator, you use the idea of use the least common denominator idea. Okay. Again, we're using the same algebraic rules, right? That were used in your algebra course, right? The only difference is that we're working with trig functions, okay, instead of like x, instead of x and y. Okay. As I mentioned, right? Math is a very cumulative subject. Right? The techniques you're learning, right? You're using what you learned before here. Okay, and then later on, we're going to use this for something else. Okay, all right. So let's see. Let's look at the next one here. Okay, let's say we have cotangent squared theta. We want to show that this is equal to cosecant theta minus sine theta, all divided by sine theta. So obviously here, again, just as in this example here, right, we have, we want to start with the more complicated side, okay? So we want to start with, in this case, we want to start with the right-hand side, okay? And so what we can do, again, so the strategy here is to write everything in terms of either sine or cosine, okay? All right, so let's apply that. Okay, so I'm going to start on this side, okay? So cosecant theta, right? This is 1 over sine theta. Okay. Minus sine theta, all divided by sine theta. So everything in this case is in terms of sine theta, which is really nice. And so what we can do, okay, we can use the same idea as we did over here. Okay, again, so we have what's called a compound fraction, or something they call a complex fraction. You have a fraction within a bigger fraction. So in this case, unlike over here, we have the cosine theta is here and sine theta here. So we took the product of those, okay, the LCD, right? The least common denominator. So here we only have sine theta. So that's going to be the least common denominator for this case. So we're going to take the top and multiply it by sine theta, and then multiply the bottom by the same thing. Okay, so we're going to get sine theta over sine theta minus sine squared theta. Okay, that's in our numerator. And then the bottom here, we have sine theta times sine theta, which is sine squared theta. Okay. Okay. So as you notice here, this part right here will be 1. Okay. Okay. So this is going to give us 1 minus sine squared theta over sine squared theta. And 1 minus sine squared theta is cosine squared theta. Right? All right, and so what is cosine theta over sine theta, right? That is cotangent theta. Okay, so since we have square here, this turns out to be cotangent squared theta. Okay, and that's what we wanted to show. Okay. Okay, so yeah, so I think those are the examples I wanted to go through with y'all. There's some more. There's definitely some more in the in the OpenStax book. Okay, so please read through. I believe it's 7.1. So read through that. Okay, and then we're going to from here. What we're going to do is we're going to look at some other specific type of identities. Okay, and then we're going to later on we're going to look at solving trig equations. Right. Okay, so basically we have a trig, right? We have a trig equation and we want to solve for that specific angle, right? Or the specific value for that angle, okay? So all this idea and the next few sections are all going to be applied in that case, okay? So again, if you have any questions, always feel free to email me. So I'll hope everyone has a good weekend, and I'll see you on Tuesday, okay? So hang in there.